In the vast, silent expanse of the universe, among the countless stars and galaxies, lies a mystery as old as time itself. Today, we venture into the heart of darkness to uncover the secrets of neutron stars, the universe's hidden giants. Our journey begins with the spectacular demise of a star far larger than our own sun. In its final breath, it collapses, exploding into a supernova and leaves behind a core. This is no ordinary remnant. This is the birth of a neutron star, an object so dense a teaspoon of its material would weigh as much as a mountain. Imagine compressing the entire mass of our sun, or even more, into a sphere just 20 kilometers across. This is the reality of a neutron star. Such density is beyond human comprehension, where the laws of physics take on bizarre new forms. Among these celestial phantoms are the pulsars, neutron stars spinning at unfathomable speeds. They emit beams of electromagnetic radiation, acting as cosmic lighthouses. Each pulse, a whisper from the cosmos, revealing secrets of the extreme universe. Neutron stars are not merely remnants, they are cosmic laboratories. When they collide, they warp the very fabric of space-time, sending ripples, gravitational waves, across the universe, opening new chapters in our quest to understand the cosmos. In the cosmic ballet, neutron stars sometimes find partners, spiraling into each other in a dance of destiny. Their merger, a spectacular explosion of energy, creates elements heavier than iron, scattering these cosmic seeds across the galaxy. This cataclysmic event not only forges new elements, but also radiates gravitational waves, offering us a glimpse into the fabric of space-time itself. The journey to understanding neutron stars began in 1967, with the discovery of pulsars by Jocelyn Bell Burnell and Anthony Hewish. These pulsating stars, later identified as rotating neutron stars, opened a new window into the cosmos. Today, cutting-edge telescopes and observatories across the globe continue to unravel the mysteries of these celestial objects, proving that our quest for knowledge knows no bounds. Neutron stars are not just remnants of stellar giants or beacons of gravitational waves. They are also cosmic alchemists. In the heart-stopping moment of a neutron star collision, the universe's most precious metals are born. These cataclysmic events are key to forming elements heavier than iron, including gold, platinum, and uranium, underscoring the interconnectedness of the cosmos. Neutron stars, with their extreme gravity, serve as cosmic laboratories for one of physics' most profound theories, Einstein's general relativity. These dense remnants of stellar giants allow astronomers to observe the effects of gravity in ways no other objects can. The intense gravitational fields of neutron stars cause the fabric of space-time to warp, bending light and distorting time itself, phenomena that were once purely theoretical. Observations of pulsars in binary systems, especially those in close orbit with another neutron star, provide critical tests for the predictions of relativity, such as the emission of gravitational waves during their merger. These cosmic events not only confirm Einstein's century-old theory, but also guide us in the search for new physics that might lie beyond. Through neutron stars, we are able to probe the universe at its most extreme, testing the limits of our understanding and peering into the very heart of space-time itself. In the silent watch of the night sky, neutron stars remain largely invisible, yet their secrets impact our understanding of the universe. These dense remnants of stars challenge our perceptions, reminding us that in the vastness of space, mystery and beauty exist in the most unexpected places. Thank you for joining us on this journey into the heart of cosmic mysteries. If you're intrigued by the wonders of the universe and thirst for more adventures among the stars, make sure to subscribe, like, and share. Dive into the comments below with your thoughts and questions. Until next time, keep gazing at the stars, for they hold stories waiting to be told.